A battery tends to be taken for granted, and that's unfortunate because a battery also tends to fail without much of a warning. When it does, your customer will very likely be stranded. It's an inconvenience that always seems to occur when your customer has the most urgent need for transportation. Usually it's the first really cold day after the end of summer. Even in most dealership service departments, the battery is usually passed over for evaluation, unless the customer has had some kind of a cranking problem. The philosophy is, if it isn't broken, don't fix it. But when it starts to get cold outside, well, batteries are going to start failing, and it's important for you to find them before your customer does. Since the introduction of the General Motors special tool J42000 battery tester, it's never been easier to test a battery. Even so, some technicians have been a little hesitant to use the tool after years of using a carbon pile load tester. This is a normal reaction to what technology experts call a paradigm shift, which is any major change in a method of accomplishing a task. For this edition of Buick Know-How, we went to Burr Ridge, Illinois, just outside of my hometown in Chicago. We're going to hear from former GM service technician Dan Cox, who now works at Midtronics. Midtronics is the company that designed the J42000 for General Motors. Dan is going to give us a quick tour of the J42000 and tell us how to get the most out of this new tool. While we were in Illinois, we stopped by Ray Buick in Chicago to talk to technician Andy Fabris. Andy placed third in the 1997 Buick Best National Competition. Andy has some diagnosis tips and shortcuts to share with you. Finally, I'll demonstrate the updated procedures for RFA Module Programming. First, let's get started with Dan and the J42000 Digital Battery Analyzer.
Hi, my name is Dan Cox, and I'm a member of the Midtronics battery testing team, here to introduce you today to the new J42000 electronic battery tester for General Motors dealers. This tool is introduced as a service tool designed to enhance your capabilities on the modern vehicles in guaranteeing that the battery is up to serviceable condition. The J42000 uses a fundamentally different technology than the load testers that have been around for a long time. This uses a technology that was originally developed by Motorola, and it's a way to quickly, safely, and accurately analyze the state of health of a battery. In other words, giving you a clear indication of how much plate surface is available for energy exchange, even at low states of charge. The J42000 uses what's called a conductance test. What this unit does is it takes a small amount of DC energy from the battery under test, converts it into an AC voltage. It reapplies that to the battery and measures the current that flows in response. From that calculation, we're able to give you a determination about how healthy the battery is in relation to the rated CCA that you dialed into the tester prior to test. The conductance test can be used to detect defective cells, opens, or shorts, which will limit the battery from producing the desired current. When using the J42000 electronic battery tester, the first indication you look for is any kind of loose battery terminals, physical damage, or leaking battery posts, which would normally cause corrosion around the battery. If the battery passes the physical inspection and there are no leaks, connect the battery tester to the terminal posts on the side of the battery. Proper connection is essential to get an accurate battery test every time. The J42000 uses a special Kelvin connection to each battery terminal. That means we have both an AC and a DC terminal, accomplished through the serrated edge, which is insulated via special washer from the body of this clamp. A poor connection message will be displayed on the screen if you don't have full contact on both terminals with both the serrated edge and the body of the clamp. If there's no display in the J42000 tester, it is likely that one of two conditions is present. Either the battery is below 5.5 volts, and in that case it's too low to power the tester, or it's simply a reverse connection. The display screen will indicate select test in vehicle or out of vehicle. In this case, we are in the vehicle. Simply press enter. It reminds you to use terminal stud adapters when appropriate. Now it asks you to select the rating. It's currently displaying 600 CCAs. This battery is rated at 690, so we need to scroll upward. Each step takes you 5 CCAs. If you hold the button depressed, it will run to whatever value you stop at. Now we've dialed in 690. We hit enter. You get the message that it is testing at 690 CCAs, and at approximately 6 seconds, we have a decision and a battery result, 12.57 volts. It calculates 799 available CCAs, and the decision, good battery. If you depress the code function, it's the 7-digit alphanumeric, in this case a 9X09E-25. This code should be documented and reported on any vehicle with an electrical service complaint. One of the test messages you may receive is surface charge detected. That means that the voltage is elevated and you'll need to remove the surface charge before proceeding. To dissipate the surface charge, the tester will prompt you to turn on the headlights for a period of time. When the message changes to turn headlights off, the unit will automatically retest when the voltage stabilizes. It's automatic. One of the messages that you may receive is a question before or after charging. Every battery that has not been charged by a current-limited commercial charger is considered before charge. If the battery has been fully charged by an auxiliary charger and it has gone to a current limit and tapered to 0, that is considered after charge. One display message may be, is the battery above or below 32 degrees F? This message is used to try and help you never condemn a battery simply because it's cold. A cold battery cannot produce the same amount of energy as a warm battery. Simply indicate to the tester which condition the battery is in. If it's a warm battery, say above 32, and the test will proceed. If system noise is displayed in the test set window, there's electrical activity in the vehicle that will not allow it to test at this time. Make sure all electrical loads are off, even something as simple as closing the car door. Body computers, electrical faults, or parasitic loads will also cause this condition. If you turn off all electrical loads, the tester will begin to test automatically when it sees the load has disappeared. If the noise continues, you'll have to disconnect the battery from the vehicle and then proceed as if it were an out-of-vehicle test. One of several windows will be displayed at the conclusion of the test. If it says good battery, it means exactly that. It's a serviceable battery that's fully charged and can be returned to service. If you get a result that says good recharge, there may not be enough reserve energy in the battery to start the car. You need to fully charge the battery and retest again prior to turning the car back to your customer. If the message in the window is charge and retest, that means that the battery falls into a category where it can't make a sound decision. It needs to be energized or fully charged to identify whether or not it's healthy enough and serviceable. Fully charge the battery on a current limited charger before attempting to retest. If the message is replace battery, it means exactly that. The battery has fallen below the minimum acceptable standard and should be replaced. Document the warranty code which appears after the conclusion of each test. If any of the test results are other than good battery, it's important to take, before removing the battery from the vehicle, disconnect the battery terminals, clean the battery posts, install and tighten the appropriate stud adapters, and retest. Install the test leads on the battery and select out of vehicle test because the battery is now disconnected from the vehicle. Select enter. We are using the terminal adapters and we are already dialed into the 690 CCA rating of the battery. Simply press enter to initiate the test. Again, the window displays that it is testing, and in approximately 6 seconds we get a result. The battery test in this case is 12.60 volts. We're measuring 793 CCAs, and the decision is a good battery. You can now press the test code button, the 4th button on the tester. Make sure you document the warranty code from the test result when you use the terminal stud adapters.
We're back, and joining us is Charlie Geip, service engineer from Delphi. Charlie was involved in the planning stages of the J42000 battery tester. Charlie, this new tool tests batteries in a much different way than a load tester. What would you say to a technician who doesn't think the new tester can do the job at least as well as a load tester?
Chuck, prior to the release of the J42000 tester, our battery engineering group evaluated the conductance technology that the tester utilizes and found it to be an accurate method for testing batteries. Both the carbon pile test and the J42000 test, if done properly, are accurate methods for testing the battery.
Do you think that load testing will eventually become obsolete?
Chuck, load testing a battery is still an accurate technique for testing or determining the condition of the battery. The J42000 is also an accurate method as well, although it does have some benefits. Namely, the tester is smaller, lighter, easier to use. It can also test the battery in a lower state of charge with accuracy, whereas the carbon pile can't.
Now, I know you've done some autopsies, so to speak, on failed batteries. Can a battery have a temporary or intermittent condition that could ever fool the new tester?
Chuck, by nature of the fact that an intermittent connection may be inside the battery, if the test is done and the intermittent condition does not exist, the tester may not detect that. Intermittent conditions like broken welds inside the battery may occur, and if when the test is performed, the intermittent is not there, the tester will not detect that.
So what would a technician do in a situation like that?
If a technician suspects an intermittent problem, like a broken weld inside the battery, one of the things he can do is place a load upon the battery prior to testing. A load, say for instance, like turning on the headlights, cranking the engine, or possibly using the carbon pile. If he can get the intermittent condition to occur while performing the test using the J42000, he'll find that the battery is in fact bad.
Charlie, thanks for stopping by. We're always glad to have you here on Buick Know-How.
You're welcome.
Now let's go to Ray Buick to get some diagnosis tips from one of Buick's best.
Hi, I'm Andy Fabris. I'm a Buick technician here at Ray Buick in Chicago near Midway Airport. The best way I've found to repair and find short circuits is with a test light that I've made. It's made from a brake light bulb and an old brake light bulb socket wired so that both filaments will light. And then I've just put two lead ends on it because it can be used, so it can be used in a bunch of different ways. This vehicle has a problem. The left high beam headlamp is inoperative. I've already determined that fuse 16 was blown. That leads me to believe that there's a short in the circuit for that left high beam. So what I'll do is install my test lamp across the fuse socket. Right away I can see that this circuit probably does not have a short because the lamp is not lit at full intensity. That's because it's a complete circuit through the resistance of the headlamp. If this circuit had a short currently, this tail lamp would be lit at full intensity. I can show the difference in that lamp's intensity by grounding the non-power side of the fuse terminal. And you should see the difference. Once again, if there was a short, it would be that bright. The way I'd try to duplicate the short circuit is by looking in the service manual and finding out where the related wiring runs. And then I'll go and visually inspect the wiring as best as I can, and then very carefully either tap components that the wiring runs past and wiggle the wiring to try to duplicate the short circuit. I'd probably start near the fuse box look at the harness, wiggle it while watching the bulb to see a flicker. You want to be careful not to move the harness too much, so you don't move the short away from where it originally was. There we are. Here we are. We've got a power wire rubbing out of its retainer and clamped between the headlamp and its housing. Okay, I've repaired the shorted wiring and put the wiring back in its intended retainer. Put a new fuse in it, everything's okay. A few little tips. Finding a short in a circuit that has a present short is pretty much the same technique, but you're looking for the light to go dim while you're shaking things around. A few other things. Trying to locate the short circuit, you want to look for anywhere that the wires are in an area that could rub against sharp corners of metal. You want to look for any kind of modified wiring, like trailer hitches, around trailer hitches, or for trailer lighting, or for radios or alarms. One thing to keep in mind is you want to keep the bulb away from anything that can melt, because if it's at full intensity, it can get pretty hot. You also want to look for harnesses that are out of their retainers. That's a good sign that it's not in the correct path, so it can be clamped by things or rubbing against things. One common mistake I've seen technicians make is they'll start to try to find a short by installing a fuse or a circuit breaker. The reason I recommend not doing this is sometimes it can burn a present short away from its ground, and it'll make it harder to find the short. You never fix anything that way. Another thing to keep in mind is you may not want to use this technique in a circuit that contains a solid-state module. In the event another technician is using your parasitic drain switch tool, J38758, here's a good alternative. All you need is your amp meter and a decent battery. What I'll basically do is hook the amp meter from the positive side of the battery to a good positive stud somewhere on the vehicle other than the battery itself. In this case, I'll use the junction block here. You can use the alternator stud. Then I'll run another jumper from the extra battery's ground terminal to, say, a good engine ground. Then what I'll do is disconnect the vehicle's battery so that any current draw from the vehicle will be taken out of this battery. Okay, here we go. We got over an amp of current flow. I'd say we have a problem with this vehicle. One tool I found that works well for testing voltage pulsing circuits, sine wave and square wave, such as crank sensors, cam sensors, distributor pickup coils, and vehicle speed sensors type circuits, are logic probes. They're a very sensitive tool that picks up changes in voltage especially pulsing voltages. There are all different kinds. They all basically do the same kind of thing. This type you can get at your local hobby electronics store. It works well, but it's not as heavy duty as others you can get. These two I got from local tool suppliers. They both work well. This one's kind of nice because it also has an audible feature to it. If you have a pulsing signal, it'll make a beep when it pulses. I can demonstrate how sensitive it is and how it displays a pulsing circuit by just touching the positive battery terminal with my left hand and touching the tip of the tool with my right finger. You see the one LED turns from green to red. That tells me that I'm going from a low 0 voltage to a higher voltage, in this case 12 volts. The smaller LED will light yellow when there is a pulsing signal. I'll hook it into a 3x signal from an ignition module to between the ignition module and the PCM on a 3800 engine and show how that works. Okay. Right now we see a yellow light on the LED. That means it's receiving a pulsing signal. Often I've found on the 3800 engine, a customer would complain of an intermittent stall or die out, and many times the car will restart. And when you hook up your scan tool, you see you'll have history codes. On this vehicle, which happens to be a 95 Riviera, you'd see codes either P0321 or P1361. They have to do with the IC circuit or the spark reference circuit between the ignition control module and the PCM. If you were to follow the flow charts for these codes, it may steer you in the wrong direction. I have found quite a few examples where the crank sensor will lose its sync signal. In other words, the circuit will open internally in the crank sensor and will cause these two codes to set. Many times we can duplicate the customer's concern by running the engine with the hood closed and getting the engine hot. That seems to cause the crank sensor to fail. I can simulate what happens when this crank sensor fails with a harness here that I've made up. On the older 3800s, like 91 through 93, the code that'll set will be 17. On the newer ones, such as this one, from 94 and up, you'll see the P0321 and the P1361. To simulate the malfunctioning crank sensor, I've installed a harness in between the ignition module and its harness connector. What I'll do is open the sync circuit. This will set the code P0321. Okay, the sync circuit is now open. The P0321 set. And I believe that's the point that the customer would possibly notice a stall. When the car is restarted, the code 1361 is set. And that set current until the customer shuts the vehicle off and restarts it again. And as long as there's no other problems with the crank sensor, both of these codes will be in history. And that's what you'll notice when the car comes into the shop.
In 1996 and later Park Avenue, LeSabre and Riviera models with the personalization option, the key fob may not change the memory seat, HVAC, or mirror position settings after the RFA module has been replaced. The settings may change with the memory seat buttons, however. One possible reason for this is that the factory default settings of the replacement RFA module might not be properly configured. Each time an RFA module is replaced, you must activate the options in the new RFA module with the Tech 2. This is done on the Set Options screen. Navigating to this screen is a little different, depending on which year and model you're working on. See your know-how reference manual for model-specific procedures. This is a 1998 Riviera, so we'll go to the Set Options screen by going to Remote Function Actuation, then Special Functions. In Section 9K of the Service Manual, you'll find a list of remote keyless entry RPO options. The option package V4R includes all possible RKE options for the Buick G-Body. You can determine if the car you're working on has the V4R option by reading the Service Parts ID label. In the Riviera, it's under the spare tire cover. Follow the prompts on the Tech 2 and make sure that all of the installed options are enabled, even though the customer might not use one or more of them. The active options are determined when you program the individual fob transmitter options, which is the next step. It's also important to disable any options that are not installed. For example, if the theft option is enabled in a car that does not have the theft option installed, the system might arm and disarm, but only with the fob. If the door is opened with the key after it was locked with the fob, the horn and lights may go off. Then, your customer might begin to think the theft option is installed on their car and that it isn't working properly. That's an instant comeback. Another source of possible misdiagnosis is option number 3, which is a factory use module testing option. This option turns off the theft illumination lamp after 2 seconds if it is enabled, and after 30 seconds if it is disabled. If you see it on the list, make sure it has been disabled. Well, that's it for this edition of Buick Know-How. Next month, we'll be taking a look at the latest anti-lock brake system called DBC7 in action on the 1999 Regal. Don't forget to log in at the Buick Know-How website the next time you're online. Good luck with the quiz, and thanks for watching. For Buick Know-How, I'm Chuck McLennan.